In Chapter 2, Section 3, we're going to be looking at product and quotient rules and higher order derivatives. Our objectives: find the derivative of a function using the product rule, find the derivative using the quotient rule. We're also going to find the derivative of more trig functions, and we're going to find a higher order derivative of a function. So I don't have a note card, but if I did, what would be on that note card would be these formulas right here. All right, so what happens when we're asked to find the derivative and we have a product of two variable factors? Okay, well, we wish that it would be as easy as just finding the derivative of each of the variable factors and multiplying together, but sadly no. So here's the formula. So this says find the derivative of a product of two variable factors. So that's going to be the first factor left alone times the derivative of the second factor, so fg prime, plus the second factor, g of x, times the derivative of the first. So fg prime plus gf prime. All right, what happens when we see an equation and we want to find the derivative of it, a function, and it's a quotient? Well, an option might be to use the quotient rule. Sadly, this derivative is not f prime over g prime. It's more involved. So the derivative of a quotient, if we use the quotient rule, is another fraction, another quotient, and in the denominator, we're going to take the denominator of the problem and we're going to square it. No derivative down here, just take the denominator and square it. Then we begin the numerator with the denominator, not the derivative, just g of x, and we multiply by the numerator. So g times f prime minus, and then it's the numerator, f of x, minus the derivative of the denominator, fg prime. Another way to think about this is maybe a little kind of acronym. So if you think about a fraction and you're going to be using the quotient rule to find the derivative, think about f of x being what's in the high part of the fraction, and think about g of x being in what's the low part of the fraction, high and low. Okay, if you can kind of remember this, it might help you with this formula. Okay, so the derivative of a quotient, if I use high and low, is going to be low d high, so low, okay, which is g of x, times the derivative, that's what the little d stands for, of high. So low d high, derivative of high, which would be f prime, minus high d low, high d low, which would be f of x times the derivative of low, which is g prime, all over low squared. So low d high minus high d low over low squared. All right, and the four remaining trig functions that we want to investigate their derivatives, or at least look at them. So these derivatives all can come from applying the quotient rule if we were to rewrite tangent. So the derivative with respect to x of tangent can be thought of, okay, well, tangent can be rewritten as sine x over cosine x. It's one of the trig properties, identities. And if we were to apply this low d high minus high d low over low squared and clean it all up using some of our trig identities, we actually get this nice secant squared x. So really it's about memorizing the derivative of tangent goes to secant squared. Now I won't derive this by using the quotient rule, but I'm sure you could find it somewhere if you were interested, probably in our textbook. All right, I'll come down here, derivative of cotangent. Well, we could rewrite cotangent of x as cosine over sine and apply the quotient rule for differentiation. So if we did low d high minus high d low over low squared on this quotient, and we did some cleanup on that, we would get negative cosecant squared x. So basically it just boils down to, we got to memorize that the derivative of cotangent goes to negative cosecant squared x. So tangent goes to positive secant squared x, but the cofunction's derivative is negative cosecant squared x. All right, same thing over here. We could rewrite secant x as 1 over cosine x, apply the quotient property, but basically we just have to memorize that the derivative of secant is secant x times tangent x. So it's the product of secant x and tangent x. The derivative of cosecant, the cofunction of secant, is going to be negative cosecant x cotangent x. So secant's derivative is positive, cosecant's derivative is negative. Secant's derivative begins with secant multiplied by tangent. Cosecant's derivative begins with negative cosecant and then times the cotangent function. So you might want to put those on a note card and just kind of every once in a while glance at them and try and begin to memorize those. All right, so how do we use these new rules? Okay, so it says find the derivative of each of the following. So in number 1, I'm going to inspect. I'm going to inspect this this function, and I notice that x to the 9th is a factor that has a variable in it, x, and cosine of x is another factor, and it has a variable in it. So if I kind of think about applying the product rule, I might want to think about this as being my f part and this is my g part. Not to confuse this f with the entire function f of x, I'm just using these to help remind me about this product rule formula. All right, so I'm going to kind of pull over here. So I'm going to go right to the derivative. So f prime of x is going to be f left alone times this derivative of cosine. So I'm just going to do a setup on it, derivative of cosine x. I'll come back and write in what that derivative is in my next step. So f times g prime plus g, the second left alone, times the derivative with respect to x of x to the 9th. Right, so these derivative operators tell us we're not done. We still have more work to do. So right here, I'm going to kind of look at this first term. Well, I still need to find the derivative of cosine. Well, that's going to go to negative sine x, and it needs to be multiplied by x to the 9th. So how I arrange that is I'd put the negative first, x to the 9th, and then sine x behind it. Plus, now I'm coming over here and I want to finish this derivative. So the derivative of x to the 9th is the power rule. That would be 9x to the 8th. It needs to be multiplied by cosine of x. Typically, we'll put that up front, the 9x to the 8th times cosine x. It doesn't look real good when you put 9x to the 8th behind cosine of x, because it almost suggests to somebody that you need to multiply those two together, and we don't. And that's it. Unless you want to take out a common factor of x to the 8th, but that's good. Okay, let's just jump down to number 3 for right now, and then we'll come back to number 2 in a second. All right, so I want to find the prime. Okay, just kind of inspecting what y is equal to. I notice that this is a term, and then I have a second term right here. So in this first term right here, I notice that I have 6x can be thought of as my f function, and then sine x is my g function. So f and g are both factors with an x in it. So I'm going to have to do the product rule here. And when I look over here at this next term, it's also going to have to be the product rule. Because think about x to the 5th as being f and cosine of x being g. So we have 2 product rules within problem number 3. Here's another strategy that might help too. If I'm focusing on this first term of 6x sine x, I know I'm going to need both f prime and g prime. So if I wanted to kind of come over here and say, okay, well, in that term, f prime, go ahead and find the derivative, is 6x. And when I look at g, I also need g prime for my formula. Derivative of sine goes to cosine. So sometimes it helps to kind of do a little list over here. All right, so jumping into the derivative of this first term, okay, it's fg prime. So 6x times cosine x plus, I'm at the plus sign, plus g f prime. So g and then f prime. So I'm going to multiply these two together. Probably going to put the 6x up front. Wait a minute. Let me come back. I don't want to restart this video. F prime is not 6x. F prime is just 6. Yikes. Do not want to start all over. So sorry about that. So f prime is just 6. So let me come back here. This is f g prime. So 6x times cosine x, we're good there. Plus g f prime. G and f prime. These two get multiplied together. So that would just be 6 sine x. plus, now I'm at this next term right here. Terms are what you add or subtract, and this term has two factors in it. So I might come down here and come up with fg prime for this term. So f is x to the fifth, so that means f prime is going to be 5x to the fourth. G is cosine of x, so g prime is going to be negative sine x. So moving back into the problem, I think I'm going to have to swing down here. So for this term right here, it's fg prime, so f g prime, so x to the fifth times negative sine x. So I'm going to pull the negative in front. So actually it's going to become plus minus or just simply minus x to the fifth times sine x, and then plus gf prime, gf prime. So 5x to the fourth would go in front of cosine of x, so plus 5x to the fourth times cosine x. And then I'm going to rewrite this, hopefully line it all up in one line. No, plus minus, so that'd just be minus x to the fifth. Quite lengthy. I don't see a common factor that you could take out of all four of those terms, so we'll just leave it as is. All right, coming back up here to number 2, I saved this one for now because you might notice that for this function, if we want to find the derivative, we don't just have two factors, we have 3. And the product rule isn't just restricted to having 2 factors. You can have as many as you want. So the formula is similar, but a little bit different because we have to include that third factor then. Okay, so I do know what I'm going to need is the prime of all of these factors here. So if you want to think of this as f and g and h, and not to confuse that f with that f of x, but just for the purposes of managing the formula. If this is f, g, h, I'm going to need all 3 of these derivatives. Let me just come over here to the side. So f prime would be 9x squared plus 5. G prime, we're looking at the g factor, derivative of x is 1, that'll go to 0, so g prime is just 1. H prime, derivative of this factor, well, derivative of x is 1, that goes to 0, that's also 1. Right, and here's the formula that we could use when you have multiple, more than 2 variable factors. So f prime of x can be thought of taking f, g, and h, but taking the prime of f and multiplying by g and h left alone. Plus, and then I'll write down f, g prime, and h. So the prime of g times the remaining 2 factors without their derivatives. And then plus f, g, h prime. So if I applied this formula to this function, I want to go grab f prime, 9x squared plus 5, and then record g and h left alone, plus, now I'm at f g prime h, so f left alone, f left, g prime is 1, and then h left alone, which is x plus 4. Plus, now I'm at the third term in the formula, fg. So fg, there's f, left alone, g, left alone, and then h prime, which is 1. So f prime of x, I'm just going to do dot, 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 because if you weren't going to leave it just like this, then you'd have to multiply all this out and collect like terms. That'd be a lot. So I'm just going to say, all right, this is a safe stop. We'll just leave this one here. All right, 4. Looks like we don't have a product or a quotient rule. We haven't even seen a quotient rule yet, but we don't have a product rule here because we have 2 individual terms. Now we're just dealing with these trig derivatives up here. All right, so y prime equals All right, so cosecant of x, let me go find that derivative. Cosecant's derivative is negative the product cosecant x cotangent x. So I already have a negative in front, so applying that to this negative would give us cosecant x cotangent x. I'm at the minus. Cosine from a previous lesson, that derivative is negative sine, so that negative will make that subtraction plus, and we record plus sine x. And we're just going to leave it at that. Now we could do some identities here. We could change cosecant x to 1 over sine and possibly cotangent x to cosine over sine, but that's really not going to be any prettier. As a matter of fact, it'd probably be uglier. So we'll just walk away from this answer this way. Studying 5, our objective is to find the derivative. So here's a term and here's a term. Okay, I do see a fraction, but it doesn't necessarily always mean that I have to do quotient rule. As a matter of fact, for this one, I'm not going to do the quotient rule. I'm actually going to rewrite this, bring the x to the 4th out of the denominator, not the 9. The x is the only thing with the exponent of 4 on it. So I'm going to leave the 9 in the denominator, bring x to the 4th up as x to the negative 4, and I'm going to use the power rule from last time. So notice I'm not putting down h prime of x because I have some algebraic rewrite work to do. So this becomes 8/9 x to the negative 4, and I'll just bring down minus secant x. Let's not find the derivative of secant x until we're ready to find the derivative of everything, because then that would be like, what notation would we put over here if one has a derivative and one doesn't? So do the algebraic rewrite, everything's prepared. Now let's apply some derivative rules. So for this term, that's from the other lesson. So the power rule says multiply negative 4 into the fraction. So that's multiplying the two numbers here. We get negative 32 over 9. Keep the x, subtract 1 from the exponent, so that'll go to negative 5. Now we're at secant. That's a trig differentiation rule. So every term may have a different differentiation rule. So this is minus derivative of secant from above is secant x tangent x. So I can walk away from this. This is fine, but if we don't want to have any negative exponents, then what we could do is drop x to the 5th back down to the bottom with the 9 and have the fraction negative 32 over 9x to the 5th, and then minus secant x tangent x. Either are fine. Either answers are fine. All right, bottom right here. To me, at first glance, that looks like a product rule. It looks like cosine x would be your f and secant x would be your g. So if you want to jump right into the product rule, because we do have f prime and we do have g prime from our differentiation rules, and you can do that and you'll be able to clean it up, and you're actually going to get an answer of 0 when you clean it up. Now, with trig functions, I'm always a little bit suspicious. I might take a moment and see if I can maybe clean up this function by using some of my trig identities. And what I do notice is that secant of x is really 1 over cosine x. So I'm not going to the derivative. I'm thinking about some trig identities. Keep the cosine of x. Parentheses aren't necessary. Times secant x is 1 over cosine x. Well, these are going to divide out, and I'm going to end up with my function is really equal to 1. But remember, we're supposed to find the derivative, so let me go to the derivative of a constant, and the derivative of any constant is 0. So again, you could have done fg prime and gf prime, the product rule. You're going to get a bunch of trig stuff, but eventually those things are all going to cancel, and you're going to get a final answer of 0. So it'll still result in an answer of 0, even if you did the product rule and didn't see these trig identities. All right, yes, it's time to practice the quotient rule. All right, so find the derivative of each of the following. So number 7, okay, I see that I probably can't do any kind of algebraic rewrite here. In a previous lesson, if we were dividing, if the denominator was a monomial, one term, we could split everything up and simplify and apply the power rule. I think we did. but notice that we have a binomial down here. So this is probably best found, the derivative is best found by using the quotient rule. So f prime of x equals, so I'm thinking about this being high, the x being high, and the x minus 8 being low. So thinking about that little rule on the other side, this is low d high minus high d low over low squared. So I begin finding my answer by starting with low and squaring it. No derivative. So what's low in the problem is x minus 8, and we square it. And we'll just only leave it like that. We'll never multiply that out. Just go ahead and leave it like that just in case we clean up the numerator and we can cancel some factors. So always leave the denominator like low squared, unless it's a simple cleanup, you know, where you can square a 2 and a 2 or something. Then we're going to begin the numerator with low, derivative of high, derivative of x is just 1, minus high d low. So high is x, derivative of low, again, is just 1. So usually there's a little bit of cleanup with the numerator on this. This would just be x minus 8 minus x. You can cancel. Let me get our final answer. All right, let's go ahead and do, I'm going to drop down to do number 9, and then I'll come back and do 8 and 10. Okay, looking at 9, if I want to find the derivative, I'm not dividing by a monomial, one term, I'm dividing by 2. So in that case, I'm probably going to jump right into the quotient rule. And again, as a reminder, on the front page, this was a quotient right here, this term was, but this is just a monomial, and it's an easy rewrite to where I would avoid the quotient rule and use an easier power rule to find that derivative. Here, not so much. We're going to have to use the quotient rule. So start with low, square it. Start the numerator with the low, derivative of high. So derivative of 3 is 0, derivative of negative 4x is negative 4, derivative of negative x squared is minus 2x. So this is low, derivative of high, minus, not plus, minus, high, go ahead and put that in parentheses, derivative of low. And derivative of low would be 2x. We have quite a bit of cleanup in the numerator. We're going to have to distribute these two and then also distribute the 2x from behind here. And then collect some like terms. And quite possibly something might cancel with the denominator. So we at least have to investigate that. Okay, so foiling negative 4x squared. Outside would be negative 2x cubed. Inside plus 20. Last term's plus 10x. Okay, I'm going to distribute the 2x into each of these terms, but then also subtract. So that would be 6x minus 6x. These two multiplied is negative 8x squared, but minus a negative 8x squared would be plus 8x squared. Negative 2x cubed, and that would become plus 2x cubed. All right, and I bet some things are going to collect or cancel. Yep, this will cancel with that one. I don't think anything else cancels, but I can certainly collect like terms. So f prime of x equals, so let's see, I can put together these two terms. So that's 4x squared. Lightly cross them off so I can still see them, but they're gone. Minus 4x, and then plus 20. I can see now in the numerator, I could probably factor out a 4, And if I factor out of 4, that still won't help me canceling with something in the bottom. So I'm just going to stop right here. Okay, now we'll go to 8. It says find f prime and then find f prime of c. So it looks like we need to find the derivative using the quotient rule. Once we get the derivative, we'll plug in pi over 3 for all the x's and use our trig values to help us maybe simplify that. Okay, I'm going to go ahead and do the quotient rule. So low squared, low, derivative of high is cosine, minus, never plus in the quotient rule, minus high times derivative of the low, which is just 1. Okay, at this point, we've found f prime of x. Now let's plug in pi over 3 to find f prime of c. So f prime of pi over 3. So every x is pi over 3, so pi over 3 times cosine of pi over 3. I'll be going to the unit circle in a minute, getting that value, minus sine of pi over 3. Ugh. X or c is pi over 3, and then I'll square that fraction. Pi over 3 is just pi over 3, nothing you can do with that. Cosine of pi over 3 on the unit circle is a half. The sine of pi over 3 up there at pi over 3 is square root of 3 over 2. If I wanted to square this fraction, I probably would. It's pi squared over 9. So pi squared over 9. This is what I was talking about earlier. I typically don't square if it's a binomial, but if it's just like one monomial, it's easy to square that fraction by squaring the top and squaring the bottom. Okay, and bring this up here. So multiplying together, we get pi over 6. This is a complex fraction. We could walk away from it. Typically, we'd want to clean it up. A lot of ways to clean it up. For me, I think I want to get rid of all these fractions. So what I'm doing is I'm going to be looking at all the denominators. Look at 6, 2, and 9. Let's get a least common multiple of 6, 2, and 9, meaning the number that 6, 2, and 9 are all factors of is 18. I think if I multiply by, well, I know, if I multiply by 18, everything in this answer, I will at least get rid of all these fractions here, fractions and fractions. So I'm going to multiply the top by 18 and the bottom by 18. So multiplying by 18 on the top and multiplying by 18 in the bottom. That's just multiplying by a form of 1. All right, multiplying 18 and pi over 6, 6 will go into 18 3 times. So I'll be left with 3 on top and the pi on top. So I'll have 3 pi. I'm at the minus sign. Square root of 3 over 2 times 18 over 1. 2 divides into 18 9 times. That leaves you to multiply 9 times the square root of 3. And in the bottom, when I multiply these two fractions, 9 will divide out 18 twice, leaving 2 pi squared. All right, and one last one with the quotient rule, number 10. Okay, it is a monomial. You could separate, that's one way, or you could do the quotient rule. It's really up to you. You have a choice here. You could put the square root of x underneath 8x. You could put the square root of x underneath 7, rewrite and apply the power rule, or you could get right to the quotient rule. So I'm not sure we've dealt with something with the square root at the bottom. So I think I'm going to avoid the quotient rule because this is a monomial. Let me go ahead and put 8x over square root of x minus the 7 over square root of x. And as a reminder, square root of x is x to the 1/2. I think the quotient rule is pretty much straight up, not bad, but by splitting it up, it allows me to remind us that we could change the square root of x to x to the 1/2. And if I wanted to clean this up and avoid the quotient rule, I know that with properties of exponents, I can subtract the exponents. So f of x is equal to, when I look at this first fraction, 1 minus a half is positive half. So cleaning that up, that becomes 8x to the 1/2 minus, here I would have to just bring up x to the negative 1/2. And then I don't have to do the quotient rule, I can just do the power rule from the other day. So let's find this derivative and then this one. So 1/2 times 8 is 4. Keep the x, subtract 1 from the exponent is negative 1/2. Multiply, that becomes plus 7/2. Keep the base of x. When you subtract 1 whole from negative 1/2, that becomes negative 3/2. And again, like the other day, if you don't want negative exponents, you can make them positive. You can drop down x to the 1/2 down here, or if you wanted to change it to the square root of x. 2's in the bottom already. You could drop x to the negative 3/2 to the bottom. And since 3 is the numerator, it would be the square root of x cubed. So with quotients, sometimes you have an option. You might want to do an algebraic rewrite on it first, stay with the function, clean it up with some algebra, and then apply maybe the power rule. Or you could have gone right to the quotient rule on that. You might have been more comfortable now knowing the quotient rule to do that. Just know that that answer will look quite different than this answer, but they are equivalent answers. So we'll continue in the next video.